Now, the new topic that we're looking today is finding the solution to simultaneous equations by graphing. So you might remember the first thing that I said about these simultaneous equations is that they are a line. So any equation with an x and a y in it and no powers is a line. Any equation with x and y in it and no powers is the equation of a line. Because it's a formula that shows us the relationship between the x variables and the y variables, which means we can draw the graph of that line. We know how to do that, don't we? We find 2 points on the line, draw a straight line through it. So let's do an example where we're asked to find the point of intersection. The point of intersection is the solution to simultaneous equations of 2 lines by graphing. So we're told that these are our 2 lines. P is the line y equals minus a quarter x plus 2, and Q is the line y equals x minus 3. Using the same axes and scales, draw the lines P and Q. So P and Q are just names that we're giving the lines. Instead of saying number 1 and number 2, we're just giving them a letter to represent the line. It doesn't really mean anything. It could be a name. I mean, this could be Fred or Bob or Sive or Julia. It doesn't really matter what this is. What we are being asked to do, though, is to draw the lines on the same graph. So this is the way that we say on the same graph. Using the same axes and scales means on the same graph. So let's look at the 2 lines that I have. So my first line, the line P, y equals minus a quarter x plus 2. This line is in the form y equals mx plus c. So this is in the form y equals mx plus c, where my slope is going to be minus a quarter. So it's a negative slope, it's sloping downhill. And my y-intercept, where it crosses the y-axis, is at y equal to 2. Okay, so it's been a little bit since we've done this, and that's a reminder of the information that's given to us when our lines are in this format with y equal to something, and on the other side, everything else on the other side. So for Q, y is equal to x minus 3, and that's also in the form y equals mx plus c. So the slope for this line is going to be the x coefficient, it's 1. It's going to be a positive slope, 1 over 1. And my y-axis comes from y equals minus 3. Y equals minus 3. So in the y direction, I know that I'm going to need to go between a 2 and a minus 3. So we might as well give plenty of space to this. Hopefully this will work out well enough. We need to go up as far as 2. We'll go a little bit further than that, and we need to go down as far as minus 3, and we'll go a little bit further than that as well. So the first thing to do is to draw our axes, and then we'll mark in the y-intercept and the slopes, and then we'll draw in our lines. So for this line, my y-axis, I went a bit wonky there, my y-axis, and we'll put my x-axis going through the middle, take up all the space that I have. To make this nice and clear for myself, I'll use 2 boxes per point. So for my y-axis, I'll go 1, 2, 3, 4, 5, 6, and I'll go down -1, -2, -3, -4, -5, -6. I get asked all the time, how do you know how far to go? And the thing is, you don't always, but you have the y values for the y-intercepts, and you know you need to go at least as far as those, and it's always a good idea to go a little bit further. Usually going as far as 5 or 6 is enough. 4, 5, 6, and -1, -2. Remember, your lines for your coordinates should be right on a line, right on the corner of a box, on the intersection points of the boxes. -3, -4, -5. And I have more space if I need to put in more space as well. So there's my x and y axes drawn in. Let's look at my first line. So the line P, the y-axis is at 2. So I'll put in that point. And then my rise over run, I'm going to use the slope. So the rise over run here is 1/4. The minus just means that it's going downhill. So that means that every time I go over 4 boxes, I go down 1. So over 4 and down 1. And that's how I'll find my next point here. So I go over 4. Now, boxes, I'm going to go coordinates. So 1, 2, 3, over 4, and down 1. Okay, I can do it again if I need to. 1, 2, 3, over 4, and down 1. Right, so that is going to be my line Q. And let's draw it in. You should always do your lines in pencil until you're really sure of them. You can always go over them in pen once you're happy that you've done it right. If you make a mistake, you need to be able to rub it out and fix it without having to go and draw your axes all over again. So that's the line P, and like I've said before, it's good practice to write in that is P given by y equals -1/4 x plus 2. So I've labelled it as well, and I know which one I'm talking about. The second line then, I'm going to use the y-intercept of -3. So it's all the way down here, -3. And my slope is 1. So the rise over run is 1/1. That means when I go over 1, and I go up, because it's a positive slope, I go up 1. So I go over 1 and up 1, over 1 and up 1. You can keep going like that if you want to. Over 1, up 1. Whereas this one was down 1 and over 4. So now you can see this line is going to intersect over here. So I join my dots together as carefully as possible. A sharper pencil would have been good. And like I've said before, you just keep going. Now, sorry, I've actually not made that as accurate as I could have, which is why it's a good idea to do it in pencil. And nobody's going to penalise you if there are pencil marks, rubbed out pencil marks on your page as well. So there we go, this is my second line. Once I get to the point of intersection, I'm happy enough with it anyway. So again, let's label it. So this is the line Q, which is given by y equals x minus 3. Y equals x minus 3. So I've answered this correctly using the same axes and scales. Draw the lines. Let's lift this up so you can see this in one go. Using the same axes and scales, draw the lines P and Q. And I've done that, and we can see that they cross over. So there's a follow-on question now. Part B says, use your graph. I'll write it down here. Use your graph to write down the point of intersection of P and Q. Okay, so my hope is that you can see that straight away it's there. So what are the coordinates of that? Well, the x coordinate is 4 and the y coordinate is 1. So I'm saying that the point of intersection of the graphs is, just using my graph, 4, 1. So that's the answer. I'm just writing it down straight away. Now, if you'd made a mistake in your graph, the important thing, you can still get full marks for this. The important thing is that you use your graph correctly to write down the point of intersection, where they cross over. Where they cross. Okay, the follow-up question to this then is where it starts to get back to what we've been doing all of last week. So part C asks us to use algebra to verify your answer to part B. And what are we going to do here? We're going to solve simultaneous equations. So we're going to solve simultaneous equations where my two equations are P minus 1/4 x plus 2 and Q y equals, sorry, that should have been y equals as well, y equals x minus 3. Okay, so what am I going to cancel here? Well, the y's are already set up. This is really like the homework that you were doing on Thursday. Now I know I have a fraction, but I also have a calculator, okay? So I'm going to cancel y. I'm going to cancel y, and I'm going to do it like this. No change. Again, I'm going to use 1 and 2 because we've been using 1 and 2 for everything else that we've been doing. No change to equation 1, and I'm going to take away equation 2, the second equation. So no change to equation 1, even with that quarter in there. Y is equal to minus 1/4 x plus 2, and take away equation 2, minus y is equal to minus x plus 3. I must change the signs of each part there. The y's cancel and they leave me with 0. What am I going to do here? I have negative 1/4, take away 1. Where's that coming from? Minus 1/4 minus 1. It's just the coefficients that I put together, and that gives me minus 5/4. So minus 5/4x, 2 plus 3 is 5, and this is the equation that I have to solve. So I'm going to solve minus 5/4x plus 5 equals 0. We know how to deal with fractions. To deal with fractions, we write down our common denominator, and then we multiply every single part of our equation by that common denominator. So what happens? I've got 4 times minus 5/4x plus 4 times 5 equals 4 times 0. Those 4's divide into each other and they cancel. Minus 5x plus 20 is equal to 0. And now it's much easier to solve. Minus 5x is negative 20. I divide across by the coefficient of x. X is minus 20 divided by minus 5. Use your calculator if you need to. Minus 20 divided by minus 5, and we get a plus 4. So x is equal to 4. Then I sub back in to find the matching y value. It's easier to sub it into equation 2 because I don't have to deal with fractions. So instead of y equals x minus 3, I can say y is equal to 4 minus 3. So that means y is equal to 1. Well, x is 4, y is 1, so x comma y, the point of intersection, is 4, 1. And is that what we got from our graph? Let's have a look. 4, 1. It is. Absolutely is. So we have verified what we did graphically. We have verified it algebraically. So that whole week of learning to do simultaneous equations was also we could do this type of question. Now I'm going to get you to practice with one of these tonight, and we're going to take our time going over more and more of these. Okay, thank you.